Good morning. Myself Deepak Seth here. I'm working in image graphics as an application engineer. So we welcome you all for our image graphics Wednesday webinar. For today's webinar topic is storage tank design as per API 650 part 2. Part 1 is our first tank webinar. So these are the topics that mainly we are considering in our tank software. So topic 1 and topic 2 is already covered in our last webinar, part 1 webinar. So for this webinar, part 2 webinar, we mainly consider external pressure as per Appendix V. Here we can evaluate the external pressure capacity of the tank. Then we will see the nozzle stiffness as per Appendix P, seismic analysis as per Appendix VE, venting requirement as per Appendix API 2000. That's all 7, 8, 9, 10 points that we will discuss. We will plan again for the next webinar, so in that we can discuss on the same. So design of a storage tank for external pressure, Appendix V. This appendix provides minimum requirement for tanks that are designed to operate with external pressure. Annexure V, this Appendix V, ensures the main component of the tank like shell, floor and roof, etc. are strong enough to withstand the imposed external pressure. So with the help of this parameter, we can evaluate the external pressure capacity of the tank. To see more detailed things regarding the Appendix V external pressure calculation, now I am going to open a example file which is related to the external pressure example. So this is my tank software. I have an example for the external pressure. Now, for the external pressure, in webinar 1, we already discussed about this shell and the roof data. Once you finish all the steps here, then in this roof data, shell calculation, you need to provide all the thickness of your shell courses. Once you finish all these steps, we'll move to the external pressure. In the external pressure, you need to specify the external pressure. Then you need to specify the elastic module of roof plate material, allowable compressive stress for bottom stiffener, small allowable tensile stress for top stiffener, and the smallest allowable tensile stress for the roof and shell and the stiffener. These are the values you need to provide in the tank input requirement. Once we finish all this required input, now it's time to do the analysis. So once we analyze this is the output window of the tank software. Vane and the roof, these two topics we already discussed in the webinar 1. If you want to know more about this topic, please refer to our webinar 1. So now for this webinar, we will see this API 650 Appendix V external pressure. This is it is the red color. Once any report which is coming in the red color, it means there is some problem. So what is the problem in this external pressure report? If you want to know that, click on this external pressure report. So once you come down here, we'll see that this is the value which we have provided in the input data. As per the same software is calculated Px, Ps is maximum, is external pressure. As per the same software have calculated the thickness requirement to overcome of the external pressure. So the minimum thickness requirement, it is saying 7.922. But if you see our thickness, what we have entered is 4.7. It means it is less than what we have entered. So to overcome from this thickness and the external pressure, software is suggesting us to provide a stiffener ring, and for the stiffener ring it is providing the spacing also, and it's saying number of stiffener ring is 1, actual stiffener spacing is 6.512 meter, and where is the location? The 6.51 meter is distance from the top. So if you come down, so here is the number of stiffener is 1. This much radial load is coming, stiffener load is coming on the stiffener, and the inertia is required area and stiff area. So these are the complete calculation you will get from our external pressure calculation. These are the brief calculation. It's not the detailed calculation. If you want to see that the formula based detailed calculation, how this value, this stiffener ring value is calculated, and how the this thickness is calculated, the stiffener ring is calculated. So you need to go in this detailed calculation, Appendix V, external pressure. This icon is coming separately here. Once you click here, you'll get the formula based detailed calculation report for the external pressure. How this 7.922, the minimum required thickness for the external pressure is calculated. As per this formula, software is calculated the minimum required thickness for the external pressure. To overcome this external minimum requirement thickness, software is suggesting you to put a stiffener ring. What will be the size of the stiffener ring, and what will the location of the stiffener ring, how much load it will come on the stiffener ring, all the details calculated here. Now if you close it, you will see software, as we have seen in the output report, that software is suggesting us to put one stiffener ring. So once you close this, software will show you the one stiffener ring as well graphically. Now we will move to our second topic, which is nozzle stiffness as per Appendix P. Under the Appendix P, nozzles are subjected to mechanical loading and temperature that are differ from the shell temperature where differential expansion takes place. Tank will evaluate the stresses in the nozzle to shell junction. Nozzle stiffness window allow you to specify up to 15 low tank nozzles, and data specification you can include external piping load from a pipe stress analysis like Caesar2 software if it is available with you. So we will go and open one example file for the nozzle stiffness, and we'll see how we can put the value in, how we can calculate the nozzle stiffness, and where to put the value, and what are the value we need to enter in the software. So again, for this I will go and open this nozzle stiffness file. You can see here, this is my nozzle is located here. I have given only one nozzle. This is the icon for the nozzle stiffness tab. Right now in this model we have entered only one nozzle, but up to 15 number of nozzle you can specify in our storage tank. How to specify the second nozzle or third nozzle? So like this, we have option here to add a new nozzle. Simply say new nozzle and give the description of the new nozzle. I'll discuss on this nozzle. This nozzle, we can put the description of the nozzle, what is the name of your nozzle, then we can put the height, we can put the location of your nozzle from the bottom plate, like right now this is a half a meter, is a 500 mm. Nozzle outlet diameter you need to enter here. Delta temperature is nothing but the difference between the normal operating temperature and the installation temperature. And then modulus of elasticity, then the reinforcement on shell or nozzle. That we have two options is available. Where is the reinforcement? Nozzle, either nozzle or the shell. So this tab indicates where the nozzle is reinforced is located. This entry is used to interpolate among the charts in API 650 Appendix P. If reinforcement is on the shell is indicated, Appendix P make some assumption. Assumption is like the reinforcing pad thickness is equal to the shell thickness. The pad diameter is twice the nozzle diameter. So these assumptions are implicit in the curve which is presented in the Appendix P and that are automatically considered by the software in your result. Now, if you provide the pad, then there's pad thickness, you to split the nozzle weight, and if you have a data, you can enter here radial force. If you have this some piping, this output load, something is coming on your nozzle, that you can enter at this point, and then use PVP 1279 for stiffness. So what is this PVP 1279 for the stiffnesses? And when we should check this window. So if you go through Appendix P, so Appendix P, this Appendix P states that this particular appendix is valid for tank in excess of 36 meter in diameter. So if you have a tank whose diameter is more than 36 meter, you can use Appendix P. But if you have a tank whose diameter is less than 36 meter, then what you will do? So in this case, tank use PVP 1279 as an alternate method to compute the nozzle stiffness for a smaller tank. So PVP 1279 was developed specifically for tank which is less than 36 meter in diameter, and you can say like when your tank is outside the scope of Appendix P. So in this case, you can change this, check this stiffness, this icon to get the nozzle stiffness for the smaller tank. Right now, if you see that the diameter of the tank, which we are doing right now is 40. So 40 meter is the diameter of our tank. It means it is coming under the limitation of the this Appendix P. So right now, if it is more than 36 meter dia, we can use Appendix P. So go for the nozzle flexibility. In this case, we are not going to check this model because this diameter is more than 36 meter. If it is less than 36 meter, definitely we can check this icon. Once we fill all this information, now it's time to analyze it. A fresh file. Maybe I use that file. I have changed something in that file. So I will sorry. I'll take this file. Okay. Maybe I did some correction in that file. So there's a problem with this file. Okay. So the same thing is available here. It's time to analyze it. Or it will work. Okay. It's working. So now, if you see the nozzle flexibility load, so in this tab, you'll get the complete stiffness, force, moment for the nozzle, for your end-to-end nozzle in case of user, test, and design condition. All three conditions, software will give the stiffness value for your nozzle. And how this data is calculated? This is just an overview of the result. It's not a detailed calculation. If you want to, sometime your this inspector AI, okay, they did the detailed calculation how this value is calculated. So if you want to have this kind of this thing, so we have a different tab, separate tab for that detailed calculation. This is nozzle stiffness calculation. In this nozzle stiffness calculation, you will see the calculation with the formula. It's a pretty detailed calculation. Okay, now we will move to our third topic, which is seismic analysis as per Appendix E. So in the seismic analysis, tank may have to withstand seismic disturbance in the normal course of their service life. When a tank is subject to seismic loading, it experiences a sudden horizontal acceleration because of the seismic movement. This acceleration caused the shell to undergo force from the contained liquid, as well as a sudden movement of the shell and roof, which are unwilling to move as the ground escalates. So once the earth is moving, so this is connected. This is the bolted or founded with the with your foundation. So what will happen? This plate will try to move along with the acceleration, but this part and this part, okay, so you can say that it will hesitate to move as the ground escalate. The force from the sloshing product imposes a hoop stress in the shell. This hoop stress must be sustained by the strength of the shell plate. So Appendix E of API 650 address this aspect of design. Here we will see how we can calculate. Here we'll see what happens when the vessel has sulfuring liquid inside after a seismic disturbance, and how we can get the shear resistance force, combined hoop stress, and the freeboard value. So to calculate these parameters, I'm going to open the file which is related to the seismic design. Okay, so the same thing, you need to enter all these parameters, then this icon is related to your seismic design. You need to enter the minimum yield strength of the bottom plate, minimum yield strength of the material, then the seismic user group. We have the one, like 1, 2, 3 that you can take it is from the API 650 code, which is suitable to your location. Friction factor is 0.3. As per API 650 section E 7.6, the maximum value for the friction factor is 0.4. Next is the importance factor is 1.25. As per basically API recommends that this value not exceed 1.25, and this value only used for the emergency services. Then the initial anchorage type, we have two anchorage type. One is the self anchorage and other is the bolt anchorage. Earthquake, we have two categories of this in terms of earthquake. One is the mapped one, or other is the site specific one. So define the earthquake type as either mapped or site specific. Then the site class, and you need to enter some more information in the seismic data. Once you fill all the information over here, we'll go and analyze the file, and we will see how to calculate the hoop stress, how we can get the freeboard value, whether this is under the limit or not. Then also you can check it. So if you go in the result, if you see in the result, this is the separate icon for the seismic analysis. Every time if you for this tank software, first result will be your simple result, just overview of your output. If you want to have a detailed result, again, like the other things, other calculation, we have a detailed calculation over here, seismic analysis calculation. There you will find the complete formula based calculation. So right now we'll go in this seismic analysis result. In the seismic analysis result, if you come down, anchor bolt is not required, then because we did not choose the anchorage type is the bolting one, we have choose the self type. That's why software is saying no. If you check that the bolt type, software will do the calculation for the same. If you come down here, height of closing web, and then required freeboard value. Here they have calculated the hoop stress for all the 6 cell courses, how much hoop stress is coming in your cell courses, the storage tank, and what are the allowables for the same. And finally, it is saying in the summary that seismic cell stress check is passed, base shear within the limit is passed, hoop stress within the allowable is passed. Now, if you want to know that how this freeboard value is calculated, this if you want to know the detailed calculation of with the formula, everything, so definitely you need to go in seismic analysis calculation. In the seismic analysis calculation, if you come down, so software is calculated the required freeboard value from here. With respect with the help of height of this sloshing wave is a multiply by 0.07 as per table E-7. Now we came to know these are the freeboard value. So like this, if you want to know something related to this based on the detailed calculation, definitely we have the different icon, a separate icon you can say to have the detailed calculation for the same. Now so we have some 5 minutes time. So let me go through this. I will take 2 more topics. Our next topic is the venting requirement. So venting requirement software is following as per API 2000. API 2000 concern tank venting and flow rate with filling and emptying the storage tank. So this API 2000 venting data is used to determine the necessary venting for in-breathing, out-breathing, and the fire. To know more about this venting requirement, I will go and open the tank file which is related to the venting requirement. If you open this venting requirement file here, this is the icon. You can see this is the icon for the venting requirement API 2000. Click here. You need to fill the data. What is your emptying rate of the liquid which is present in your storage tank? Then what is the filling rate, the liquid flush point, then the boiling point. So you need to specify the liquid flush point, and then the temperature of the liquid flush point, fire point, then the boiling point of your you can say the temperature of the liquid boiling point. You need to enter here. Then this environmental factor, this factor you can get it from API 2000 as per your location and as per your requirement. We have they have that table 4A of API 2000. There you can find the environmental factor as per your requirement. Once we fill all this information, now it's time to analyze it, and we'll see how software is calculating the result. If you analyze it, now this is the icon for the API 2006 edition venting calculation. In the venting calculation, these are the in-breathing. For in-breathing thermal effects, required air volume is 93.2 cubic meter per hour, and this is for the out-breathing, and this is calculation for the required air volume. So how much air volume is calculated, how much is the required, software is giving the calculation for the same. Then close it, and I will take two more topics: the griller's review and cycle life. So griller's review is nothing but it will follow this Appendix I. So this option consider the tank that are supported on beam under the floor, or you can say the base plate also. The thickness of the bottom and the spacing of the beam are analyzed to ensure the bottom is stable under the liquid load, and that spacing is does not that spacing is does not require too thick in regarding of the floor plate. So these are the things that we can see in the Gleesman's review. And next is the cycle life. So cycle life will go with the Appendix M. So cycle life used to determine the allowed number of fill empty cycle that tank undergo with a detailed stress analysis. So these are the things that we can perform in our tank software. So with the help of this, I am going to end my this tank part 2 webinar. So if you have any question which is that you need to clarify, please send me the question on support@igfzco.com. So thank you, thanks once again to give your valuable time to us and to join this webinar. Thank you very much.